Artificial intelligence in healthcare is evolving at lightning speed. We're moving past automating simple tasks and stepping into the complex realm of clinical decision-making. Today's medical workflows require far more than static verification. Historically, traditional AI models have struggled with the dynamic, long-term nature of service delivery. Merging a patient's historic context with their future progression involves a massive level of complexity. Enter MedGemma 1.5. This new technology brings advanced interpretive capabilities to multimodal volumetric datasets. By combining 3D data with printed medical texts, it provides an innovative holistic data integration tool. So, what exactly is MedGemma 1.5? It's an open, multimodal generative AI system built on the powerful Gemma 3 architecture. It's tailored specifically for high-dimensional medical data. Unlike previous models, version 1.5 effortlessly handles 3D scans and whole slide images, all packed into a compute-friendly 4 billion parameter size. MedGemma 1.5 goes beyond flat 2D images. It interprets 3D volumetric data from CT and MRI scans for true depth and volume assessment. Furthermore, it integrates whole-slide histopathology, interpreting massive tissue samples simultaneously. This allows the model to synthesize information across large tissue samples rather than viewing isolated segments. It also features temporal and spatial reasoning to track disease states over time via current and historical X-rays. Plus, it extracts structured clinical data, parsing unstructured medical records with incredible accuracy. And with seamless speech-to-text integration via medASR, voice dictation translates directly into advanced, explicitly reasoned workflows. Let's look at the use cases. Volumetric 3D radiological analysis provides automatic findings from multiple CT or MRI slices instantly. Meanwhile, longitudinal disease monitoring automates the comparison of past and present X-rays. This gives real-time evaluation of disease stability, a task that previously consumed hours of manual comparison. Real-time anatomical localization highlights regions of interest in live mode. For pathologists, automated triage allows them to examine various patches of a whole slide together to efficiently reach a diagnosis. Crucially, its compute-efficient 4B size allows for offline clinical decision support. This is a game-changer for low connectivity environments and strict data privacy requirements. Under the hood, it uses the Gemma 3 decoder-only transformer architecture. It utilizes the SIG-LIP image encoder to extract high-dimensional visual features for the large language model. By applying grouped query attention, it boasts a context window of at least 128K. Developers can validate, adapt, and scale these prototypes directly to production using Google Cloud's Vertex AI and Model Garden. In practice, this model acts as a developer tool with a clear operational workflow. The journey begins with use case definition to identify specific clinical objectives. From there, developers select a model from the MedGemma collection, moving through a crucial phase of validation and adaptation to ensure it perfectly fits the intended clinical setting before scaling. Looking ahead, the integration with medASR creates real-time multimodal feedback loops. Imagine a clinician's spoken dictation dynamically adjusting bounding boxes and diagnostic summaries on the fly, turning static validation into conversational fine-tuning. This conversational fine-tuning process continually refines clinical reasoning without the need for tedious manual data curation. Furthermore, the model is primed for federated learning. Weights can be updated across decentralized networks of hospitals without sensitive patient data ever leaving the secure local environment, solving critical data sovereignty issues. Deploying this federated AI enables institution-specific adaptation at scale. This creates a self-evolving medical AI ecosystem that actually becomes more demographically representative and robust with every deployment. The performance leaps are staggering. On the chest imaginome benchmark for spatial understanding, MedGemma 1.5 reached an IOU of 38%, an absolute jump of 35% over its predecessor. For electronic health record comprehension, it achieved a 90% accuracy on the EHR QA. Radiology classification improved by up to 14%, and histopathology generative fidelity saw a dramatic increase. These results indicate the model has matured from a pure classification tool into a system with profound spatial understanding. Furthermore, it achieved a massive 78% retrieval macro F1 enhancement in extracting structured data from unstructured reports, and hit a record 69% on the MedQA benchmark for medical reasoning. Ready to get started? MedGemma 1.5 is accessible via GitHub, Hugging Face, and Google Cloud Model Garden. It includes a unique Developer Foundations license that supports on-premise use. However, remember, it is a developer-level tool, not a medical device. All results must be validated by a professional, and it should not be used to definitively rule out disease. By assembling compute efficiency, high-dimensional imaging, and temporal awareness, this AI gives developers the keys to truly understand patient trajectories. It is the gateway from fragmented data to absolute clarity. If you are a professional working in health tech or AI, you don't want to miss the MedGemma revolution. Like this video, hit subscribe for more cutting-edge medical AI content, and check the links in the description to read the full article.